So let's get started. Bismillah ar-Rahman ar-Rahim. What we are talking about was the D flip-flop. The D flip-flop removed the SR flip-flop's 1-1 state, which was not allowed, right? So in D flip-flop, what we did, we fixed that by giving the inputs in a complement form. So if you give one input and second input in a complement form, so there will never come a chance of 1-1 as an input, because if one input is 1, then another input gonna be 0. If this is 0, another input will be 1. So there's no chance of 1-1 coming in the inputs. In that case, we will never have this case of 1-1, because it was unreliable depending on which gate is faster, right? We did a lot of things on that. So what we said is, if this is our D flip-flop, for example, this is my D flip-flop, we tied the inputs, okay, and give complement form it to the another guy, and then this is my Q and Q complement. So it will never, this D flip-flop will never, it need to have a clock also, right? Then only we can say this is a flip-flop. So this will never ever will have the situation of 1-1. So our cases will be, if the clock is 0, then your whatever the inputs we have, okay, it will not have any effect. Say for example we have a D here input, right, and this is my Q and Q complement. If clock is 0, we have nothing here. If clock is 1, this will in fact be a memory state, okay, the state will be memory. If the clock is 1 and the D is 0, that means it will be 0-1, because if D is 0, the 0 will go here. What will go here? The 1. 0-1. So will the set or reset? No, this is the D flip-flop, right? Because we have a situation like this. I told you yesterday, we discussed that it is like this, okay. Then there is a NAND gates here, the clock is here, CLK, sorry, and the D is here, okay. If you are giving it 0, so it will be 0-1, but it will come here as a 1-0. So 1 on the top, and on the top there is 1. Huh? Will reset or set? Sure? Yes, because we discussed a lot of things about it. It will reset. Good, you're perfect today. Because if it is 1 here, 0 here, it will reset, right? So if it is 0, that means it will reset. So what will be here? Q will be 0 and Q complement will be 1. That means it will reset. So if the clock is 1 and D is 1, so if D is 1, okay, so we will have 1 and here we'll have 0, right? So what will be here? That means if we have 1 here, the 1 will go here and the 0 will go here. What will be here? 0 and 1. Means what? Exactly. So what will it set or reset? So it will set. So what will be set means Q is Naureen. So you क्या? I'm asking question to answer then. Set में Q क्या होता है? उसकी भूल जाओ, मैं कह रहा हूँ set में Q क्या होता है? और Q complement? Okay. ये हमारा D flip flop है. So it has removed this 1-1 state, and this is remembering things beautifully. This is the memory we use. You D flip flop to build our memory in calculators, etc. But I told you that 1-1 state, which is not being shown up here, we want to use that. We want to use the full features of our flip flop, all the features, even 1-1 should be used. So to do that, we have a next flip-flop which is called as JK flip-flop. It is same as SR flip-flop. Only thing is we have an additional feedback loop. Remember, we said combinational circuit and sequential circuit. What was the difference? You tell me, Wasim.
Sequential circuit सर उसमें आउटपुट
Yes.
डिपेंड करता था उस पे प्रीवियस इनपुट
पे डिपेंड हो रहा था previous output
Previous output is also coming back. So we have a feedback loops, right? That was the combinational circuit. That's what we're doing here. It's coming. The output is coming back here, right? It's coming back in the inputs. This is the combinational or sequential. In combination, we didn't have that. Example of combinational. This comes as a question. What is the difference between combinational and sequential circuit? So, what is the combinational circuit example? Adders, multiplexers, decoders. I've already done all these things. Subtractors. They were all combinational circuits. Comparators, parity generator. What we have done, they were all combinational because there were no feedback loops. But starting from the feedback loop, we started saying SR flip-flop and SR latch, and flip-flops, D flip-flop, and now JK flip-flop we are going to do. They're all sequence circuits because they have the feedback loops. And JK flip-flop has an additional feedback loop so that to use that 1-1 state, right? We want to use that 1-1 state. Are you guys getting me? So that's why we move on to the next flip-flop, only because we want to use that extra 1-1 state, which was not allowed, to make it allowed. Okay? So how we do that? We use the same SR flip-flop, only we give it a new name. They have given, I don't know why, they have given a new name, maybe to remember this. Maybe remember the flip-flop which can use the 1-1 state also is called the JK flip-flop. Otherwise the same as SR flip-flop. So what was SR flip-flop doing? It was like this. The NAND gate is here, another NAND gate is here, right? Tie them together. We know how to tie them together, right? Go here, go here, and then we had the NAND gate for the clock, etc. Another NAND gate, same, right? And clock is with it. Okay, now here was S and here was R. We call them J and K. It's same as R. Is it any difference?
No,
Only difference is now, the only difference which we make it from SR is, which I make it from the red, that I tie this output, okay, to the input of this NAND gate, and I tie this output to the input of this NAND gate. So I'm getting the last outputs back onto the NAND gate here, and this one back onto the NAND gate here, right? So you will not be confused. I will use different color because wire from we have. This is your Q and this is your Q complement. Maybe use a blue color. Like this. Sometimes you'll see in the books that they have started from here and get back to here. And here जो ये वाला है ये अपने साथ अपनी साइड से आ गया है, ये वाला अपनी साइड से आ गया, लेकिन उस वक्त देखोगे ये NAND या NOR गेट होगा, वो NOR की इम्प्लीमेंटेशन है. NAND की इम्प्लीमेंटेशन में मैं सिर्फ एक इम्प्लीमेंट दिखाता हूँ, आपको दो करने की ज़रूरत नहीं, मतलब कन्फ्यूज़ हो जाओगे. मैं दिखाता था दोनों, लेकिन लेट बी इट ओनली वन, बिकॉज आप बाद में कन्फ्यूज़ होते हैं, उसका इसमें डालते हैं, उसका इसमें डालते हैं. सो एक ही होगा NAND इम्प्लीमेंटेशन, दैट्स इट. ठीक है. अच्छा, इसको यहाँ से लेके वापस डालना है और इसको यहाँ से लेके यहाँ डालना है. बात समझ आती है? सो यहाँ से लेके इसको यहाँ और फिर इसका आउटपुट इसके इसमें जाएगा. ठीक है. बाकी ये काम वैसे ही करेगा जैसे ही करता है, लेकिन 1-1 के वक्त इसमें फ़ायदा आएगा हमें. 1-1 के वक्त अनरिलायबिलिटी ख़त्म हो जाएगी. ठीक है, क्योंकि ये इसको दोनों को 1-1 होने देगा ही नहीं कभी, क्योंकि ये जो आउटपुट्स आप क्योंकि ये Q एंड Q कॉम्प्लीमेंट है, जब एक Q एंड Q कॉम्प्लीमेंट जाएंगे ऐसे, ये कभी दोनों इनपुट्स सेम नहीं रहेंगे, ये सेम ही नहीं रहेंगे इनपुट्स दोनों, ये थोड़ी चेंज हो जाएंगे. एंड वी विल हैव अ यूजफुल थिंग देयर, that's called as toggling. Toggling means 0 becomes 1, 1 becomes 0, set becomes reset, reset becomes set, and that is useful thing. We can use that, but it is uncontrolled here. We'll discuss that Okay, one by one. So for example, I'm saying, for example, this is your J is like your S, right? And R is your K is like your what? Why is this stuck? Okay. Where is my